students, I am Dr. Jagan Mohan from Institute of Aeronautical Engineering, Department of Triple E. So last class we have discussed have been discussing about the subject power system protection, and the topic is circuit breakers. So previous class we have discussed about what is a circuit breaker. So it is basically a switching device which will break or make according to the necessity or when the fault occurs. So automatically or manually or with the help of the remote. So, and also in the previous class we have seen what is the arc phenomenon. So this is the unavoidable thing which occurs in the circuit breaker. So we have to extinguish this arc as early as possible. So there are different methods we have discussed in our last class about this arc extinction, that is high resistance method and low resistance method, which were used in high and low AC circuits, AC power or AC circuits. Okay. So today we'll and also in the last class we have discussed about what are the different deionization, that is increasing the gap, increasing the pressure, cooling the arc and gas blast. So this we have discussed in our previous class. So today we'll discuss about what are the different circuit breakers we have, and what are the advantages and disadvantages regarding these circuit breakers. So what is the uniqueness of each thing when compared to the another circuit breaker. So first we will go with the air magnetics circuit breaker. So here, that means here if you are, in the name itself it is there, if you are separating the contacts. So as we have discussed in our previous class, we know that. So the basic principle here with the circuit breaker is we'll be having two contacts. Okay, in the normal conditions, when abnormal thing occurs, so they will get separated mechanically. They will get separated mechanically due to some mechanism. Okay, due to the energizing of the coil, which will separate these contacts. So here, for extinguishing the arc, so different circuit breaker will use different method. So that's why, so based on the medium, so we are using for extinguishing, or we are keeping these contacts which are getting separated in a medium. We will keep these contacts in different medium, mainly because to extinguish the arc. So that medium is, if it is air, we are telling it air. If it is oil, we are telling it as oil. If it is sulfur hexafluoride, we are telling it as sulfur hexafluoride. And if it is vacuum, we are telling it as the vacuum circuit breaker. So air magnetic circuit breaker here. So we are using some mechanism which is not part of the circuit to attract this one coil. This coil will attract the arc. So So that's why we are calling it as the air magnetic. In the air blast, we are going to make it very fast. That is like a blast. So that's why it's called as air blast. And oil, probably we are using the oil. So in this also there are different types. And sulfur hexafluoride here, the chemical component. So we are using the gas sulfur hexafluoride as the medium. and vacuum. So today we'll mainly focus on the air magnetic, air blast, and oil circuit breakers. So the air magnetic circuit breaker. So it is the first type in the air circuit breakers. Okay. So air circuit breakers, we are having air magnetic and air blast. Okay. It is also called as the arc chute circuit breaker. Okay. So what happens here is there will be some plates which are made up of metal or insulated material. Okay. So whenever they separate, whenever these contacts separate, so these plates will enter, this place will enter and indirectly separating the arc into different parts. Okay. So that is the basic technique. And also another thing, another coil which is not the part of the circuit will come into the screen, and this will attract the arc such that this arc will pass through these plates. Okay. So that what we have said, that means it will be having number of plates between the contacts which are made up of metal or insulating material. Sometimes ceramic material, sometimes porcelain. Okay. So when the arc is struck, so in our previous class we have discussed what is the arc phenomena, why we are unable to avoid this arc. Okay. So and why and what is the necessity for extinguishing this arc, and what are the disadvantages of this arc. So if you are unable to extinguish this arc, the supply will continue to flow, and also it produces enormous amount of heat, which could damage the circuit breaker and also sometimes the entire system, that means which are in contact. Okay. So basically this arc is providing the low resistance path for the current. So until the arc exists, even though the contacts are physically separated, but it acts as they are not separated. So physically they are separated, but practically not separated due to this arc. So the basic phenomena of the circuit breaker itself is getting spoiled. So that's why last class we have discussed about what is the arc phenomena and how we are going to extinguish, and why we have to de-ionize as early as possible. So here, when coming to here, when the arc is struck, it comes in contact with series of metal plates. So in this magnetic circuit breaker, in the first air circuit breaker, so whenever they are separated, naturally the arc is struck, because before we are going to start the preventive action, the fault has started, the fault has occurred. So the fault will occur very fastly. So the fault has started already. So after the fault has acted, with a time delay we are acting. That's why we are unable to stop this arc. And even though with some delay also, we are able to do it successfully with the help of the circuit breaker. And even after this problem of arc extinguishing, or we are extinguishing it also very fast. So whenever the arc is struck, what happens here is, so here the medium will be air only, but this arc will make such that this arc will be in contact with series of plates. So indirectly we are cutting this arc into number of small arcs. Okay, that means we are dividing this arc into smaller arcs. So another thing here is that the circuit breaker is based on magnetic low out assist. So another type is, in this type we use insulating arcing plates made up of ceramic. Hence arc is first made to travel between the insulating plates to elongate the arc. So we are cutting and we are elongating the arc. So the arc is cooled by diffusion process. So here you can observe, so these are the plates. So that is the insulation and these are the plates. So these are the contacts. So an arc is struck between the contacts, and because of these plates the arc has been divided into number of small arcs. So the other type is that another type in this method is that arc shoot circuit breaker based on magnetic low out assist. So here also we are going to use the insulating plates made up of ceramic. So when the circuit breaker begins to open, a coil which is not the part of this circuit comes into contact with the current. The magnetic field created, this coil, the purpose of this coil is it will create the magnetic field and it will attract or it will force the arc to move deeper into the chute. So that's why we are calling it as the arc chute. Okay. So this magnetic coil will force this arc to move deeper into the chute. So what is happening? So the air circuit breakers, first thing is air magnetic, and there we are using a series of plates to divide this arc into different small arcs, and it will get diffused, and a coil which is not actually part of this that will come into contact with the current, and this will force this arc to go deeper into the chute. So that is about the first air circuit breaker, air magnet circuit breaker. Next thing is air blast circuit breaker. So this is the second type in the air circuit breaker. So in the name itself, as the name is telling, so it will be coming like a blast. So how it will be coming? Is it coming parallelly? Is it coming perpendicularly? Is it coming radially? So based on that, this is further divided into 3 types. Okay. So in this type, high pressure air blast is used as arc extinguishing medium. So if the blast has to occur, there should be more pressure. So using the high pressure air blast. So in the case of the fault, the air blast controlled by a blast valve. So for controlling purpose, we will be having a blast valve will open the contacts and also cools the arc. Okay, so it will parallelly open the contacts and also parallelly cools the arc. That means it is extinguishing the arc. So what happens? So when the blast occurs, the arc and the arcing products, so which the medium which is there, it has got even support for this ionization and arcing process, are swept into the atmosphere. So this is the advantage of the air method. So these minute materials which are causing the arc, which are supporting the arc, will be absorbed by the atmosphere or the air. But if there is a restricted medium, there is confined medium like oil circuit breaker, these particles will stay there. Okay. So here what happens? They are swept into the atmosphere. So once they are swept into the atmosphere, so the normal dielectric strength of the air will come into screen. So because of the high potential of the fault or short circuit, and also the ionized particles, the arc is occurring. So once we are sweeping these particles into the atmosphere, so in that area, which normal dielectric strength which should have been there will come back again. So that means, so now there is a high dielectric strength between these two contacts, and now there is no sufficient potential to break this dielectric strength. So in the starting case, there is a sufficient dielectric strength and also the distance was small. The arc has started and it continued even after the distance is more also, because of the ionized particles. So now what happened? The distance, these arcing products have gone, and there is a remarkable distance between these contacts. Okay, and there is no sufficient potential difference between these contacts. Okay, that's why the restriking. So if the ionized particles are there itself, they will normally decrease this dielectric strength. So since there is no question of this particles staying there, there is no question of occurring the restriking. So that's why. As a result, the restriking arc is prevented. And also the extinguished and the arc is extinguished consequently, and the flow of current is completely interrupted. Once the arc is gone, the current passes automatically will go. So here again there are in axial blast circuit breakers, the air blast flows in the same direction as the arc. Okay, so that's why it is called as the axial. So the air blast is occurring in the same direction of the arc. The high pressure air blast push the moving contacts away, opening the circuit, and also pushes the arc along. So this high pressure air blast is separating the contacts, and parallelly it is extinguishing the arc. So here in this picture you can observe. So this is the axial blast circuit breaker. So we are having the air valve to control the air blast. For sending the air, we are maintaining the air reservoir. And here you can observe arcing chamber. Here we are getting this is called as the arcing chamber. And you can observe here, this is the piston, this is the closing spring, this is the moving contact. So that means circuit breaker will be having two. One is fixed and another is movable. Okay. So normal air clearance for working voltage and series isolator. So this is the thing actually what is happening in the air blast circuit breaker. So from this fixed contact, normally the arc will occur. So since this is axial blast circuit breaker, you can observe. So in the same direction, the air blast is occurring. So exactly opposite to the moving contact. So moving the moving contact, parallelly increasing the distance between these contacts, that means fixed contact and moving contacts, and alternatively it is extinguishing the arc, not only extinguishing the arc, and also it will sweep the arcing components, avoiding the restriking. So if you observe here, this is diagram of the cross blast circuit breaker. So the axial means along with the arc. Here it is going perpendicular. Okay. So this is the fixed contact. So here the airflow. Here is the arc splitting. This is the moving contact. So there the force will be in the same direction of the arc. Here it is perpendicular to the arc. So So today we have seen what are the different types of the circuit breakers. So their name came based on the medium they are using for the extinguishing the arc. So first thing is air circuit breaker. So in that, air magnetic, again air blast. And next thing is oil circuit breaker. Next thing is sulfuric hexafluoride. Next thing is vacuum circuit breaker. Again, I have seen what is the air magnetic circuit breaker. So here we are using the medium is air, but the thing we have to understand. So this is the first in the air blast. This is the first in the type of air circuit breaker. So here we are using a series of plates between the contacts when the contact is separated. So because indirectly we are dividing the arc into smaller arcs and making it to extinguish. Again, here in the magnetic arc chute, we are making the this arc, we are forcing the arc with the help of the a coil which is not directly the part of the circuit. So this will produce the magnetic field and this will force the arc to go deeper into the chute. So here main thing is we are using a series of plates which are made up of metal or insulating material or porcelain or ceramic material. So these series of plates are dividing the arc, and we are making this arc to flow through this series of plates. Hence dividing this arc into smaller arcs, and we are diffusing. It is cooled by diffusion. So this is the representation here. So these are the contacts, and this is the insulation, and these are the series of plates. So you can observe, actually this is the arc. So these plates have divided this arc into smaller arcs. Okay, this is the technique we are using here for the extinguishing of the arc. So next we have seen what is the air blast. So this is the second type in the air circuit breakers. So a high pressure air, we are sending the high pressure air such that it will move the moving contact away and parallelly blasting the arc, parallelly sweeping the arcing products and avoiding the restriking. So the restrike, these arcing products will not be there after this blast. So if they are present again there is a probability of restriking the arc. So if the high pressure air is flowing in the same direction of the, if it is flowing in the same direction of the arc, it is called as the axial blast. It is called as axial blast. So here we can observe, it is the, see here, these directions are showing these force, high pressure air is flowing in the same direction of the arc. So because it will start from the fixed point to the moving point. So parallel it is forcing the moving contact away and blasting the arc and avoiding the restriking also. So here this is the cross blast method. Here the forced air, the high pressure air is not flowing in the same direction of the arc. So it is perpendicular. It is perpendicular to the arc. So the main advantage here with the air type of circuit breakers, especially in the air blast method, is it will sweep the arcing products and it will avoid the restriking of the. In the coming classes we'll continue the next thing of these circuit breakers. Thank you for listening. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.